Alright, in this session I'm going to be discussing interior lighting using GI and Final Gather and photometric lights. And the purpose of this session is really uh, to show you a technique that gives you an efficient lighting system down that gives you fast, efficient renderings. That's really what you want, is how do you light your scene up to render fast? And a lot of people ask me, how do you do that? I'm going to show you how. So we're going to go through a couple things. I'm going to show you this scene, which is going to demonstrate your indirect illumination with GI and Final Gather. And then we're going to go to a real-world scene that demonstrates how to use your GI and Final Gather using in combination with the photometric lights. So really, we should open this for you. This is how you light your scene for interiors. Method 1 is a faster rendering process. It gives you lower quality. Method 2 is a slower rendering process, but gives you better quality. So in method 1, you calculate your photon map, save it to a file, and then turn on your scene lights, and then calculate your Final Gather with your scene lights on as it's reading the photon map. And the Final Gather is set to no filter, and then you render your scene. Method 2 is basically the same except for one thing. Calculate your photon map, save it to a file, turn on your scene lights, then you're going to calculate your Final Gather with a standard filter, and then save that to a file and turn on your mental ray sky portals, and then render your scene. In the end, the result of your indirect illumination is going to look the same. The only difference really is the shadows that you get from the sky portals. In this method, you get better shadows and you get a smoother result with a combination of a standard Final Gather filter and when you're turning on your mental ray sky portals. So if this doesn't make sense, hopefully when I go through these scenes it'll make sense to you. So here's the first scene, and right now the only lighting I have is a mental ray sun right here. It's actually a daylight system, and I have 4 windows that I put sky portals on. So the first method that I'm going to show you is the faster rendering technique, and let's go ahead and let's turn off all of our, this is your rendering settings, and then here's our indirect illumination tab, and then go make sure that everything's turned off. So make sure everything's unchecked. Okay, that's off. And then reuse Final Gather. So everything's off. So right now when I render, let's check my render settings here. That's good. Okay. I'm going to go ahead and click render. See what we get. Okay, so basically right now all it's rendering is the sunlight, and the sunlight is coming through. I have a plugin. It's a timestamp plugin that will show you how to the times on it, so you can ignore that. It's a nice little plugin for Mental Ray. You can use it for Mental Ray, but basically it's a render element. And oh, sorry, it's not a render element. It's an effect. It's called RP Manager. You can download it. It's free. So so this is without any indirect illumination. So the first thing you want to do is calculate your GI, and by default I think Max switches these around, where it has Final Gather up here and then Global Illumination down here. I actually switched them. I think this is default. I switched them around because the process that you use to do correct lighting is you calculate GI first and then you calculate Final Gather. So I'll make sure Final Gather's off, and then under Global Illumination, we're not dealing with caustics, so under here, under Global Illumination, I'm going to turn it on, and by default your sampling radius should be off, so it's 500, and then usually you get, this is what you start off with, is 20,000 photons. And so the best way for me to explain this, if I just click render as is, make sure all this is all off, okay. Go ahead and click render. So it's calculating my photons right here. and this is what I get. And it's not really a pretty picture, but what it's doing is it's saying, if I go to my GI settings here, it's calculating 20,000 disks, and right now the maximum number of photons per sample are 500. So the only settings I really change here are the number of disks I have in my scene, and then my sampling radius. Now, if sampling radius is off, 3D Studio Max by default will render your disks at 1/100th of your scene file, your size. So, for example, like if this is 100 feet, if my scene is 100 feet in square feet, then my disk size is going to be 1 foot in radius. So by default, that's kind of how that works. So I don't like the way it looked. It looked kind of squashed. It looked really, there's too much noise in this scene. So basically, what I'm trying to do is minimize the noise. And all you're trying to do for GI, you can think of GI as your photon mapping as the primer for a canvas, and Final Gather as the painting that goes on the canvas. So you want to have a clean canvas to work with. So basically what we're trying to do is smooth out a lot of these. Basically we're just trying to smooth out the all this noise. And that's all we're trying to get. We're not trying to get soft shadows, or we're just trying to get a smooth surface. So what I usually do is turn on my maximum sampling radius, and it forces my radius to 2 feet. So let's go ahead and render that out and see how that looks. Oh, that's the wrong view. Okay, here's my correct view. Let's go ahead and render that. Okay, so it's not much different from what we had before. And the reason, really two reasons. The default setting was probably not much different. 2 feet was probably 1/100th of the scene size. So the combination of things we can do, we can increase the disk size, which is going to smooth out my disks, or we can increase the number of disks. To show you kind of how these disks look, let me go ahead and render this at let's say 1 inch is my disk size. I'll just show you what this is supposed to look like here. Okay, basically this is what's going on in my scene. It's rendering 20,000 disks, and they're all 1 inch in radius. And so this is what photon mapping is. And so to get that smooth result, we're going to increase this, and I'm going to try to increase it by a couple of feet. So let's go maybe 5 feet. And what's going to happen is these disks are now going to be 5 feet in radius, and they're going to overlap. So like where this disk is here and this disk are, they're going to be 5 feet, and so we're going to get some nice overlapping. So let's see what that looks like. Okay, so now we're getting a smoother result. We're still getting some unevenness, and there's a lot of noise going on. So we got when you get these changes in noise from this color to this color, it's kind of a big no-no. You don't want these high contrasty surfaces on one face. You kind of want them to smooth out, because what happens is if you get this noise in GI, when you calculate your Final Gather, you're going to get that kind of noise. So instead of increasing my foot size now, let's increase my number of disks. And I'm going to go from 20,000, let's go to 80,000. See how that looks. Click render, see how that goes. Okay, it took a little longer to calculate because now it's calculating 80,000 rather than 20,000. And what you'll notice is your scene is actually darker than the other scene. That's not really what we want. So instead of calculating, you're going to get a more accurate result, but what we're trying to get is a more smooth result. So I'm going to actually increase this to 10 feet, and we're going to lower this to say 50,000. And I'm going to click render, and as I'm rendering, I've been pausing my scene just so it's faster for you, so you don't have to wait as I'm rendering. So if it goes quicker on my computer, it's because I'm pausing the video. Okay, so we're starting to get a smoother result, as you can see. Part of the problem with increasing your disk size is you're actually getting samples from outside of your scene into your scene. So some of these, you could call them light leaks. They're actually disks that are being sampled from the outside coming inside. That doesn't really bother me so much. You know, in this scene, it's okay. My photon mapping is okay. When there's still some noise, but when we calculate final gather, it's going to actually smooth out a lot of this noise. So I'm okay with this photon map. What I'm going to do now is, when I'm happy with it, I'm going to go to my reuse final gather GI, and what you can do, you'll notice that final gather is grayed out because we're not using it. And here's my GI, or my photon map. You can write it to a file. And kind of the way these work, you can choose read-write photon map to files, or you can choose read photons only. And the way they work is this option, if you don't have a photon map that's already calculated and saved to a file, it's gonna calculate it and save it to that file. If you leave it on this setting, if it's already calculated that file, it's going to use that same file. Photon mapping is world sensitive, so when it calculates, it's calculating the entire scene. Whereas Final Gather calculates directly from your camera view. So let's go ahead and I'm going to save it to my desktop, and it's called Test Photon Map. And you can either click Generate Photon Map now, or you can click Render and it's going to generate it. So the difference is that when you click Generate Photon Map, it's going to create your photon map without rendering, whereas if you click Render, it's going to generate your photon map, save it to that file, and then render. So it's what we've seen before. Okay. So now we've got our photon map. Now we can leave it on this, but just to be safe, you can change it to read photons only. And now we're going to go to our Final Gather. So Final Gather is going to use the photon map to generate some of its light. And by default, if you turn Final Gather on, you can go to the draft setting, and this is your standard draft setting. I haven't changed anything. If you go ahead and render it, it's going to calculate your Final Gather, and remember, it's using your photon map for some of your lighting. And what it should do is take that photon map, smooth it out, and then give you a nice rendering. So it did. It smoothed out this noise that we had here. Some of the noise you're seeing here is now from your Final Gather map, not from the GI. So that's Final Gather. You'll notice that it's almost just as dark as we had with photon map, and that's part of it is because we have this noise filtering on. So I'm going to do is turn this noise filtering off, and then I'm going to clone this just so you can see the difference. Let's move it over here, and I'm going to click Render again, and you'll see the difference between standard filtering and no filtering. Already you can see that with no filtering, we're actually getting a brighter scene. Yep, we got a brighter scene. So that's basically, this is our scene right here with no filtering, and this is with standard filtering. Now you're probably wondering, why would you go standard filtering if you're getting more light with no filtering? What's happening is that when you choose no filtering, it's using all of your Final Gather points. When you switch it to standard, it's actually dropping some of your Final Gather calculations that don't fit within a certain frame of light. So you're getting a darker result, but it's smoother. And so this is kind of the technique that I use. I like to use this right here. I like to use none if I can get away with it, and it makes my renderings go pretty quick. So this is kind of the technique we're going to use. This is the first method, which is what I said is is method 1, calculating final gather no filter, and then rendering your scene. So this next method I'm going to show you is really the same, except we're going to use a standard filter and then turn on our mental ray sky portals. So this is method 1 right here. I'm going to just put this off to the side right here. And now method 2 is basically, we're going to go to standard like we had before, and what I'm going to do is turn on my sky portals. And really the way you want to do it is calculate your final gather, save it to a file, and then turn on your sky portals. So that's what I'm going to do first. Because I found that you can turn the sky portals on and write that to your final gather file, but it doesn't really affect your scene. It's just a wrong way of calculating your GI or your final gather. So what I'm going to choose is incrementally add, and much like this one, it's going to add to your scene file, and we're going to write it to a temporary, or to keep it with the same language, we can call it test. Let's call it test. And FGM is for final gather map. Save. Now let's go ahead, and what we could do is click generate final gather map, or we can click render. And so let's go ahead and click render. And remember, it's darker because we have standard filtering on. There we go. Okay, so now you'll see some magic here going on. I'm going to switch this to read only, so now it's going to read my final gather map from the test file. And when I turn on my sky portals, I've got them instanced, so when I turn that one on, they all turn on right here. So now you'll see what's going to happen here. I'm going to go ahead and click render, and voila, we have some pretty interior lighting, and we have some really nice soft shadows. These soft shadows are now from your mental ray sky portal. They produce really nice soft shadows with sampling. You can see the shadow samples are on 16. You can increase them or decrease them to your liking, but the lighting you're getting is basically the same. One of them you're getting faster render times. This 16 seconds included I think it included the final gather. This was just the straight rendering, so you can see that this is going to take a little longer. We still have some noise in these spots, but this is basically how you do that. There are ways to overcome these noises, and what you can do is, right now we're on draft setting. You can increase this to low, or you can just leave it on draft. And to be honest, I leave it on draft quite a bit when I'm doing my renderings. So these are the two techniques really for doing interior lighting. That's basically how they work. I honestly prefer this method because it's faster when it comes down to rendering. If I'm doing an animation, these shadows are kind of killers, and if you get your settings right on this, it'll save you a lot of time. So using those principles, now let's go to a real scene. Okay, let's go ahead and open my scene. I'm going to start off with a blank scene, or a scene that I've got textured, and I don't have any lights, so we're starting from scratch. So here you can see, here's my scene, and I have a camera, and I don't have any lights in my scene. So if I were to go ahead and render it right now, okay, so if I were to go ahead and render it right now, let's see, this is what it'll look like. And by default, you'll see that GI or final gather is turned on. That's just how it renders. You can see that I've got my textures, so it's going to take a little longer because I've got some reflectivity going on. I've got some refraction and reflection going on in my scene. And typically you do want to texture your scene before you light it. That's just kind of a process. A lot of times I will texture as I'm lighting, sometimes I'll light and then texture, so it's kind of a combination of both. When you're in the production pipeline, you have textures and you have lighters, and a lot of times they work back and forth because they really depend on each other. How you have something textured affects your lighting, and how you have something lit affects the way your textures are. So really they kind of work together, and it's very important to know how they affect each other. So right now this is kind of how the scene looks without any lighting. It's pretty basic. So let's go ahead and cancel this. Okay, and now we can start off with lighting. The first thing we want to do, of course, is add a sunlight, a daylight system. So let's go ahead and add a sun. And so the way you do that is go under Create, and under Systems, and then I like to use Daylight. And here it's going to ask you if you want to change your exposure to mental ray photographic exposure. Yes, I like to do that. So I'm going to go ahead and check that. So, and then you just click and drag, and it adds a north arrow. And when you let go, it's going to ask if you want to create a mental ray sky. I'm going to say yes. So now it's going to place your location of your sun, basically your distance. So you just click anywhere, and now we have a sun in our scene. So let's see if we can get to our perspective and zoom out. There's our sun. Okay. So now if we were to render, we would get some sunlight. So let's go back to our camera and click render. And what I'm going to do is just to save time, I'm going to turn off my reflections, just so we get a quick render. So one way to do that is, what am I looking for? Oh, here, under rendering algorithms, you can turn off reflections. If you have a lot of glossy textures, this will, when you're doing testing, this will go much faster when you're rendering. Okay, so now you can see we've got our sky, which is all it is an HDR file that's placed into your environment slot. I'll show that to you. And we've got some light coming through this way. So this is just basically Final Gather. That's all it is. So if you hit 8 on your keyboard, it opens your environment, and there's your mental ray sky. And all it is an HDR image file that is procedurally mapped to your sun. So as you move your sun, it changes the HDR file, which is pretty cool. It's pretty effective. Because we're doing an interior scene, here's your exposure. You can change this preset to some different defaults. We have an indoor daylight, so that's what I'm going to set it at. Or is this exposure value that Autodesk decided to name and put it at 10. Of course, if you're familiar with cameras, you can go to your camera settings, but that's kind of a different topic. So 10 is pretty good, pretty standard. Let's go ahead and render that, and I'm going to leave Final Gather on right now for just for testing. See how that goes. So you can see it's still pretty dark, but it's a lot brighter, and everything outside is blown out because of our exposure. So we're getting some lot brighter hot spots. Okay, so the next thing I really want to do, I want to orient the sun so I get the maximum light into my scene. And that's kind of a clever way to, it's kind of smart lighting, if you will. So one way to orient the sun without having to render it every time, this is Max 2011. I think you can do this in 2010. You can turn your hardware shading on. If you go to lighting and shadows right here under smooth highlights, you can enable hardware shading. Okay, and now we can enable shadows, and also illuminate with scene lights. So once we do that, now we can see some shadows. So what I'm going to do is select my sun. The easiest way to do that is to go to my select by name button and choose daylight system. It's already selected. So go here to your modifier tab and then click under Setup, and it'll actually take you to this motion, or you can just click on the Motion tab. So what we can adjust here is our north direction. So you can see as we adjust our north direction, it's going to affect our change our shadows, which is really kind of cool. So we can change our north direction, or we can change the time of the day. And depending on where the sun is, you're going to get much brighter. You're going to get a brighter rendering. So let's see how this one turns out. All right. Already, just because of the direction of the sun, we're getting a much brighter. Scene. And there are a couple other things we can do. This isn't really so much lighting related, but it is rendering related. So I'm going to open the RAM player and put that first image into my RAM player. A lot of people ask, how do I get these overblown, my windows to get blown out? How do I fix that? There are a couple ways you can do that. By default, Max renders at 32 bits. And so it's assuming that you can save it to a 32-bit file like an HDR or EXR file. And in Photoshop or your favorite post-editing software, After Effects, the such, you can control that exposure, and you can pull it down, and you'll get to see those window frames. Or in Max, what you can do is go ahead and change it from floating point to integer, 16-bit, and it's going to keep those images from blowing out, and you won't have some of those highlights. The other thing with rendering at 16-bit is that you're only going to get you can't save to like an HDR file anymore. You can only save to like a PNG or a JPEG. But for saving to a JPEG, it's a great option for not having to mess with doing your light exposures in post. So let's go ahead and stick this image in here, and you can see the difference. 32-bit, 16-bit. Now it's not that because you can't see it in 32-bit, it doesn't mean it's not there. It is. It's just when you go into your post program, if you change the exposure, this is what you get. But this is what you just get with your 16-bit without any post. So typically I like to render 16-bit because I save to JPEG anyway. I don't really worry too much about doing a lot of post work, but you can see kind of the effect that you're getting here. So for this example, I am going to render 16-bit because we're not talking about post-production, we're not talking about compositing. So I'm going to go ahead and leave it on 16-bit. So, okay, another thing we can do to test our lighting for the scene, instead of rendering it with the textures on, it can kind of get confusing as to what is textures and what is bad lighting or noise in your lighting. We can render kind of with a what do you call it? A material override. And so we can do that. We can put a material override into our scene. So I'm just going to create a material here and use this one right here. Turn off the reflection, and I'm going to leave it at 50% white, which is fine. I'm going to call this matte and enable my material override and put it in there. Part of the problem with using a material override in your scene is that your glass all of a sudden turns to that material, so you're not going to get your nice shadows. One way to overcome that is to here I created a edit mesh glass off modifier. I renamed it. It's an editable mesh modifier, and I call it glass off so I can remember what it is. If I turn it on, basically I deleted the mesh that is the glass. So in this mesh right here, oops, yeah, we don't want to show that again. I'm not going to change anything. There's my mesh for my face for my glass. Basically, I turned it off with this modifier, and so we can see what's going on now. Let's go ahead and turn off our hardware shading and use default lights. Okay. So now if we render, we'll get a white scene, and we'll be able to see what's going on. Okay, so basically all the noise you can see now is from the lighting, not the texturing, and that gives us a good place to start. So Now let's go ahead and turn off our final gather, and we're going to start our lighting. So the first thing we're going to do is use global illumination. So we're going to turn that on, and let's just go ahead and see what the default looks like at this setting. So let's click render and see how it turns out. So here's calculating my photon map, and there it goes. And wow, look how bright it is all of a sudden. It's using my photon map, and that's not a bad for a default. That's not a bad setting. Basically, you're getting 20,000 disks at 1/100th of your scene size. So that's a pretty good solution. It's not bad. You are getting some strangeness here, like in these areas. You're getting some unnatural brightness where you should have nice soft shadows, and then you are getting some noise. And so there are ways we can smooth that out. So let's go ahead and turn on, I'm going to leave it at 20,000 and turn on my maximum sampling radius, and I'm going to turn that to, before I do that, let's turn off our sampling radius and let's increase this number, because I think the disk size is okay. What I was thinking in my head was that I could increase the sampling radius. The problem with that is you're going to get even more weirdness with your lighting. So I'm okay with the disk size. Let's increase this, and we're going to try, let's try 100,000. Let's go ahead and render that and see how that turns out. So it's going to take a little longer to calculate the photon map. So there it goes. But it's really not long, and you only have to do this once. With Final Gather, you have to, for every time you have a different camera angle, you have to recalculate the Final Gather. With Photon Map, once you calculate it, you can render anywhere in your scene. So yeah, that's pretty good. You're getting a pretty nice, smooth result. You are getting some strangeness, but overall, it's pretty good, and I'm pretty happy with that. So let's go ahead and save that, and see how simple that was. I didn't even have to get into my sampling radius. You can leave it at 100,000. Now you could, if you check this, all of a sudden your sampling radius is going to be much smaller. Let's go ahead and, just for fun, to see what happens to my disk size with 100,000 disks at 1 foot in radius. Okay, that was an inch, not a foot. So you can see how small they are at an inch. Let's go ahead and increase these to a foot. That's what I wanted to render it at. So let's try a foot and see how that turns out. Okay, we're getting a lot of noise, and the reason is because these disks are smaller, they're not overlapping as far, but you're getting a more accurate result. And so that's originally there's kind of, this is the technique for lighting, and what you do is you crank up your number of GI samples, so you'd have a gazillion disks in your scene, and they'd all be really tiny. They'd be so close, because you had so many of them, you'd have them so close to each other and you get really nice soft shadows. Well, this in combination with Final Gather gives you really nice result. So you don't have to worry about increasing that. Of course, at 100,000 at 1 foot, you've got quite a bit of noise. If we increase this, let's try 3 feet and see how that turns out. Well, we're going to get a smoother result, but it's going to be less accurate. Okay, wow, so at 3 feet already we're getting a pretty smooth result, but it's not much different from what we had default setting. So it's kind of you could go either way. You could set this at 3 foot at 100,000, or you could turn that off and just use the 1/100th of the scene size. But it's really there's more noise in here that I'd want to have. So if we increase this, let's say 5 feet, it'll probably give me a very smooth result that I can work with. So let's go ahead and render that and see how that looks. Okay, that's a pretty nice smooth result, and I'm pretty happy with that. So what we can do is save that to a file. Now we are testing with a white material, so when we want to do this for real, we want to test it with, or we want to calculate our GI with the textures, because right now it's calculating a disk with the color of the material that it's calculating that disk on. So if we turn our textures on, when it calculates that disk, for example, this wall was wood, that disk is going to create light that's brown in color from the wood. So that's really what we're trying to achieve. So let's go ahead and turn off our material override, and I'm going to turn off this glass off modifier. So we've got our glass back on, and I am going to go ahead and turn my reflections back on, because it will take into consideration reflections too. So if we have a lot of light that's down here on the ground from the sun, if this wall is reflective and it's that bright, it's going to use that light. So it's just going to make it as accurate as possible. So let's go ahead and calculate like that. And then those are the GI settings I'm happy with. So now we can write it to a file. So let's go ahead and write it to a file. So let's save it to, let's call it room photo map. And because I had one existing before, I overwrote it. You can click this to delete the file, and it's going to ask you to delete that original file. You can say yes. So now what we can do is we can click Generate Photon Map. And all it's going to do is generate the photon map without having to render, which is a nice feature. So there it goes at 30%. It's actually writing it to that file. So you can see here, where's my photon map file? There it is. Right now it's at 0 bytes. But now you can see it's a 2 megabyte photon map file. So there it is, a 2 megabyte photon map file. It's sitting right there, which is good. So now we have a photon map file. We can switch to read photons only. And now when we render, we're going to have some lighting from our textured scene. So here we go. Here's a render. And I'm going to pause it. We'll see how it looks. Okay, so not bad. This is just our photon map, and it looks pretty good. If you have someone who's good at texturing, you're going to get pretty good. Your lighting is going to work off of the reflection off the materials, like I said. This rendering took, it was 300 by 600 pixels, and it took 1 minute and 37 seconds, which isn't bad. So I'm pretty happy with that. So now that we're done with our photon map and we've read it to a file, we'll move on to lighting our scene. So following our little procedure here, we calculate our photon map, and now we're going to turn on our scene lights. Well, we don't have any scene lights, so let's create them. What I like to do is really try to be as accurate as possible as far as placing my lights. So I'm going to place lights anywhere I have lights in my scene. I've got these can lights here on the first floor and second floor. So what I'm going to go ahead and do is click on my Create tab and click on Lights. And I'm going to use photometric lights. And I'm going to create a free light and just start sticking them in my scene. So here's my light. And I stuck the light in place. Make sure that as far as the height, it's in the right location. So let's go to the front view, and we're going to push it up and put it just in that right spot. So it sits right in the middle. Right there. Now there are a couple things about lights that are worth noting. Here, I'm going to zoom into this light here so we can see what's going on. Right now it is it's on, and it's casting a ray trace shadow, which is good. Right now it's a uniform spherical, which means it's going to cast lights in the down direction and in the up direction. Typically, if you're using a uniform, I like to use diffuse, because now it's much more accurate. It's casting in one direction. So that's kind of an important thing. Another thing, we're going to keep it on uniform diffuse for now. Another thing is the light shape. This controls the way that the shadows are emitted. If you have it on point, it's going to create shadow from one point. If you have it on any of these other ones, all of a sudden your render times are going to dramatically increase because not only creating from one point, but for example, if I choose disk, it's going to create 32 shadows, or it's going to take from that one point, it's going to scatter that point 32 times. So now I've increased my rendering time for that disk, for this light, from point to disk, just by changing it from point to disk. But it's kind of an important thing to understand how that works. So I'm going to keep it on disk because I can adjust my disk size and we can work with it later. I am going to render it as a point. If I can get away with it, I'll render it as a disk, but to save render time, and this is kind of another a give and take. With the disk you get nice quality, but with the point you get a really fast render. So let's go ahead and choose my radius size for now. We'll set this to disk and set my radius size so that it fits right inside. So I'm going to copy this light and instance it, and then I'm going to switch it back to point. So basically I'm going to instance it, and place it in the location where I've got all my lights. So now I've got two of those lights. So I'm going to select lights only, and I'll do it like this. Hopefully it'll go quicker. Instance, and I'm going to move it right there. Okay, so I've got one more, and I'm not quite sure if that's on the top or on the bottom, but we'll find out. I have a feeling it's on the top just because it's in the same X direction, same X location, and it sure is. It's right there. Okay, so now that I've got those ones, I'm going to copy these lights, and actually this one I'm not going to copy. I'm going to copy that one down there. Instance. Move them up just a little bit. Now this can be a tedious process, but it's worth doing just to get the correct lights in the right location. And once you have them in your scene, you almost don't really have to think about them again, which is kind of nice. Okay, so we got that one, and we got some on the bottom, and I'm going to go ahead and put them in there. I don't know if you really need them for this camera shot, but just to make things physically accurate, we're going to copy them. Instance, and there they go. They go down at the very bottom. Oops, I want to move them. There we go. And they need to be moved over a little bit. There we go. Okay, so now I've got my lights in my scene. I can go back to my camera angle, and the couple ways you can, because they're instance, all I have to do is select one, and I can turn that one off, and they all turn off, which makes it very easy. So now I can turn it back on, and it's on uniform diffuse already, and it's on disk. So I can show you, now that I've got them in place, I can show you how some of these render, to give you an example of the pluses and minuses of these shadows. So to do that, let's go ahead and I'm going to take the textures out of the equation for this scene, just to show you how some of this works. So I've got my photon map calculated. Remember, I'm reading it from file, so that's basically where that lighting is coming from. So it's rendering. Basically, it's going to render this scene without the textures, and it's going to add the lights. So that's all we're doing. So it's really, I'm using the light information from the textures with the white material. I mean, it'll look kind of funny, but I'll show you what it looks like. So let's go ahead. Before we do that, I'm going to turn off my lights. Okay, so I've got them off, and we're just going to render this matte image, and then we're going to work off that. Okay, so here's my scene with my photon map from my textured scene, but this is a matte finish. So now, if I turn my lights on and I render as a point, let's go to point, and now it's on point. So there we go, it's on point. And the default settings, I don't want to mess with these too much because these are physically accurate. These are CDs, which stand for candelas, 1,500 candles per light. So that's a typical light, and this is your typical luminant color for your light, and it's on uniform diffuse. So let's go ahead and render that and see, with those lights on, and see what it looks like. Okay, now it didn't take too long to render. But you can see I do have my lights on, and you can see in the scene right there, and it's uniform diffuse, so it's casting it in one direction. So it's not incredibly bright, but it's, you know, it's decent. Uniform diffuse means it's just casting it in one direction. If I were to turn it to uniform spherical, it'll cast light going down and going up, and so these little hot spots will get much brighter. So now it's on uniform spherical. Let's see what that looks like. Okay, in this case now my cans are bright because they're being illuminated, and you are starting to get kind of this this can light strobe just from your point light. So it's in this case it is more accurate. It's casting light, and it's as if, consider this light like a light bulb, and it's illuminating in all directions. So in this case, uniform spherical is kind of what you want, and because it's casting a point light, you're getting these hard shadows. So it doesn't take long to render. It took 15 seconds to render. Let's go ahead and turn on. Now I'm going to do something. I'm going to switch this from point to disk. And when you switch it to disk, you'll see that disk, and it'll ask you if you want to render the light shape. So an option is to switch it from uniform spherical to diffuse to get in that one direction, and then turn that on, or just leave it on spherical. We can do that. So I'm going to leave it on spherical, render disk, and it's going to render 32 samples, and you'll see the difference in shadows. So I'm going to make a copy of this, and then let's go ahead and render. Actually, you know what? I'm going to put it in the RAM player. So there's my first. Rendering with the point light, emit light from shape. The shape is point, and now we're going to render disk, and we'll see what that looks like. Okay, so it looks much nicer, but you can look at the render time and go ahead and say, holy cow, 4 minutes and 42 seconds, whereas the other one was less than a minute. But you can see that the quality is there, and so all of a sudden you're getting these. It basically is taking your same point shadow and spreading it 32 times. And it's doing that for every light. I'm going to show you. I mean, it looks nice, but it's really slow, and I'm going to show you something that's a little more accurate, or more physical and less. Won't take as long to render, and that's using your IES lights. So you can switch this from uniform spherical to a photometric web, and when you do that, you can choose a photometric file. And basically, all a photometric file is. Let's go to my library here. And I have one called Nice. All these are, it's an IES file, and all an IES file is, I'm going to show you. Open, let's see if we can do this. Open, see here. Okay, let's use Notepad. Actually, I'm going to use Always. Okay, so this is an IES file. All it is a text file with a bunch of numbers. And these numbers correspond to points in space that correlate to a light shape. And this is what that shape of the light looks like. So as I open, what it's doing is it's creating, it's conforming my photometric light to the shape of that light. So now when it casts a shadow, it's going to cast a shadow based on the shape of that light, which is pretty cool. So I'm going to show you what that looks like, and we're going to switch. You could go disk with your photometric lights, but for time's sake, I'm going to just do point and go ahead and render, and we'll see what that looks like. And it's much faster because it's no longer doing those samples. It's still doing it from point, but all of a sudden now you can see we're getting these nice, what appear to be like caustics. We're getting fake caustics. So unfortunately we lost our little highlight in our light. There are two ways we can do that. You can turn your point light to disk, and then you can render your light shape visible. And this is, if you have the time, go ahead and do this. But it's really, with any of these, you're going to get incredibly high render times. And this session is about fast render times. So we're going to keep it on point, and I'll show you another way to do it. And I like the way these look. One thing I am going to change is the color of my lights, because if let's say that it's a can light, it's an incandescent, they're not going to be white. So let's give it a more natural, a warm color. We'll give it a nice orange color. So let's try that. That's a little too yellow. Let's make it, there we go. So let's go ahead and render that and see how that looks. And hopefully the idea is that we'll get some nice blue light from the outside, and these can lights are going to give us some nice hot orange, kind of incandescent looking lights. Yeah, that looks nice. So we'll keep those lights on like that. And now we'll move on. So we've got our lights. So we turned on our scene lights, and now we're going to calculate final gather. So, and we're going to do it with no filter. So we've got our scene lights. So now let's go ahead and turn off our material override, and turn my glass back on, and we're going to go ahead and calculate. Actually, let's leave our matte on, and we'll calculate final gather like this, and then see, just so we can see the noise in our final gather. See if we're happy with it. No, that won't quite work because, sorry, I'm thinking out loud. That won't quite work because our final gather is really based off of our light from the windows. So, oh, no, it will. It'll work because I turned my glass off. So I'm just, okay. So now we're good. So let's go ahead and calculate our final gather. So we're reading from our photon map from the file, and final gather we're going to turn on, and right now everything is by default. Let's go ahead and see what it looks like with the default settings. We calculate final gather. Now remember, it's going to use, final gather is going to use the lights from my scene to calculate final gather. So here he goes. It's calculating. I think I haven't deleted my windows. Let's go ahead. Yep. Now my windows are deleted. You can see right there that my glass is right there. So now turning that on deletes my glass. So let's go ahead and render that again. Now it's going to use the sunlight. There we go. That's much better. The nice thing about Final Gather is you do get a preview of what it'll look like. Unlike the photon map, Final Gather gives you kind of a, okay, that looks pretty good. And that's at the standard setting. So you know that when we turn our filtering, or sorry, standard filtering, so now you know that if we turn our filtering off, we're going to get a much brighter scene. So let's go ahead and put that into RAM Player. So this is with standard filtering. And remember, this is draft setting. Okay, so now we're going to turn this to none. And we'll click render. Now, with having the filtering off, you will get a little more noise, but of course you get a brighter scene, and that's really what we're after. Now your scene is not really going to be this bright because once you turn your textures on, our textures are darker than the white material. So because white's much more reflective and it bounces light better, our scene is going to be darker, slightly darker than this. But as far as overall lighting, that's pretty good. And that's draft setting, and that's why I say I usually use draft setting. You can get away with some of these soft edges with turning on ambient occlusion in your material, and I'll show you how to do that. So that's pretty good. That's pretty good. We can get finer details with our final gather setting, and one way to do that, you can increase your initial final gather point density. A lot of times I like to use 0.4, and so we'll do that, and then we can go ahead and render and see what that looks like. You could also turn it from draft setting to low, but what all this is doing is increasing my point density, so I'm getting denser points in my space. Okay, that's looking pretty good. That's giving me the little more detail. Now there's still some noise that I'm getting. Some of it you can clean out by just increasing your final gather setting, but overall that's pretty good. So I'm pretty happy with that. So what I'm going to do is turn off this modifier and turn my materials back on, and then we're going to calculate final gather again. Now one thing before I do that, you'll notice that these lights, they appear like they're off. One way that I achieve that is actually with a material, and for these lights I actually modeled these lights with a material, a light material. So if we go to our materials here, you can see the light right here. This is my light material, and to make it look like it's lit, you can actually, this is Arkin Design material, by the way, you can scroll down and go to self illumination and turn it on. It'll actually illuminate your scene, and you always want to do physical units, and you can click this right here, illuminate scene with final gather, and so as it calculates final gather, it'll actually create a light from the material that will illuminate your scene, which is pretty cool. So and a lot of this noise that we see here when we turn our textures on, the textures are going to hide that noise, so you're not going to get that same noise. It won't be that visible. So I'm going to leave my point density at 0.4 and click render, and we'll see what that looks like. Okay, so it's rendering my with my materials, and it's calculating my final gather with the materials on, and from what I can see now, it looks, I'm fairly happy with the way the lighting is looking. It looks pretty good. So it's almost done with calculating the final gather. Okay, that looks pretty good. It's just finishing up right there, and it did, when I turned that material with my my glow right there, my self illumination glow, it rendered the glow with my final gather, and I'm pretty happy with it. So now let's go ahead and save this final gather map, and you have to remember that this procedure was this top procedure right here. So it's faster rendering and lower quality. but I'm pretty happy with it. I'm pretty happy with the way it looks. And you're going to get, if you're doing an animation, this is kind of the way to go. As far as your render times, you're going to save a lot of render times. And so let's go ahead and save this Final Gather map to a file, and then we'll re-render it, and we'll remember how long it took to render. So this took 5 minutes with calculating the Final Gather. Let's calculate the Final Gather, and then let's see how long it's going to take to just render it as is. So let's write this to a file, or actually what we could do is say read Final Gather points only. So we can delete the temp file right here. Let's go to our location, and let's call it room. Okay, we don't have anything right there. And what we can do is you can actually just click generate Final Gather map file. Click that, and it's going to generate our Final Gather map without having to render it. So there it goes, Final Gather map. Okay, so now our Final Gather map is done, and it's on read only. So if I click render again, it's not going to write my Final Gather map, it's going to read it only. My photon map is on read only, so we're set. And now if we want to, you can increase your sampling for your rendering. I'm going to increase it. I like to do 1 to 16 for my final renderings. In box, I'll usually leave it on box. In post, I'll increase the sharpening if I want later. Box renders faster usually, but in my render tab, that's what I like to do for my sampling. So under my indirect illumination, I'm good. So let's go ahead and render our final render for the first method, and we'll see how long it takes. And a lot of times the factor is, of course, the GI and your Final Gather are already read to a file, so those aren't really a factor in render time. What are factors are the lights that you have in your scene, your general sampling, like I had 1 to 16, and another factor is all of your glossy reflections and refractions. The more glossy samples you have in your refractions and reflections, basically the more samples you have in your scene, the longer it's going to take to render. And that's really all it is. That's the rendering game, is how many samples you have in your scene. So I'm going to go ahead and hit pause, and we'll see how long this is going to take. Okay, we're coming up to the end of this rendering, and it looks pretty good. We'll find out what the rendering time is here, and it was 7 minutes, almost 8 minutes on my crappy dual-core processor, so I only get 2 buckets per rendering, or as I'm rendering. So I don't have anything fancy. It's not I don't have like a dual Xeon or quad-core processor. It's just a simple dual-core. So it was on my slow computer. It's at 1 in 16 samples. It looks pretty good. And so that's all there is to that. Doing the second process, doing the second process right here, if you're calculating your Final Gather with the sky portals, you'll get better quality results. The only difference is that when you calculate your Final Gather, set your filter to standard, and then after you're done calculating your Final Gather, in your rendering process, create a light portal. You'll create one here, and create one in this window, and then turn your rendering on, and you'll get even a better quality rendering with smoother Final Gather samples, and you'll have nice soft shadows. You will have an increased rendering time, and on this computer it'll take way too long for me to do. But those are the two methods for doing interior lighting. And then as far as doing an animation, the way that works, I've got this camera on an animation, so it's keyed, so it just scrolls like this. So if we just play it, this is what it's doing right there. The way you do that is you could go ahead and just render your animation as usual. With the photon map, you're okay. You could basically you select your active segment, go to 100. But your final gather map, because the final gather map is based on the camera position, when you get to this point, you're going to have areas in your scene that haven't had final gather maps calculated. For example, in this wall right here, from this area on that way, you're gonna have to recalculate your final gather map. So what you can do is you can calculate one here, you can calculate one here. Typically for an animation, I like to do it every 10, 20 to 30 frames, depending on how long it is. Because this is 100, you can get away with probably doing every 20. The easy way to do that is basically to come down where we saved our final gather right here, and to generate a final gather map, you can click this arrow here, and you can say from 1 to 100, which is my my frame right here, and you can say calculate every 10 or 20 frames. When you click on that, it's going to calculate every 20 frames, and it's going to save it to that same file. It's going to save it to that same final gather map, which is this one right here. Now it's 1.48, and every time it calculates it, it's going to do it every frame. Every 20 frames, it's going to increase this file size. It's just going to dump that the new final gather map into that new file. You can also do it manually. You can change this to 20, say every 20 frames, and then you can render, and you can make your sampling very low, and so it's going to calculate the final gather. You say basically you can say render, and it's going to render every 20 frames. It's going to calculate. You can switch this to incrementally read add, and it's going to jump to frame 20 and calculate the final gather map, incrementally add it, write it to that file, and then it's going to render it. And it's going to render it really quick because you've got these really low sampling settings. And then it's going to go from 20 to 40 and so on. So in the end, you're going to have a larger final gather map. And then when you're done, you switch it to read only, and then switch your every nth frame back to 1, and then go ahead and render, and it's going to render every frame out. And that's how you do an animation. So your photon map is based on the entire scene, final gather based on your camera. And for sake of time, I'm going to show you this animation, but it's done with that procedure, and I used method 1 to do that. So I'm fairly happy with how it turned out. Procedure 2, you would have gotten even smoother results, and in your free time you can test that out, but for getting quick renderings out, this method 1 really works well. And you'll notice I haven't even you do get some strangeness in these corners. What you can do in your materials, I'll show you very quickly. In your materials, you can in your Arc and Design material, you can switch to special effects and you turn on ambient occlusion, and it'll create ambient occlusion based on that material. So you have to do it for every material. In the next coming videos, I'm going to use this same scene and show you how you can render passes. One of the passes is an ambient occlusion pass, and then the third video is I'm going to show how you can composite all those passes together to get your rendering from this to something really nice. So this is the animation using that final gather save to file technique, and it works fairly well. You won't get any flickering in your light maps, and it's pretty consistent, and you're getting pretty decent illumination, and it renders fairly quickly. As you can see on this computer, it was 7 minutes a frame, which is not too bad for a slow computer. So you can go ahead and check out my website, and all of these renderings were done with that same. These interior renderings were rendered with that same GI final gather method. So it's pretty versatile, and you can get a lot of scenes using just that same method. So in the next video, I think this video I'm going to include the max file, so you can play with it and tinker with it. But if you're interested in trying to get this to look really nice in post, check out my next video. It's going to be on render passes. Thanks.